Bismillah ar-Rahman ar-Rahim. So let's continue in chapter 8. We have this problem. Can somebody read the problem for us? Any volunteers? تفضل يا عادل.
A block of mass 1.6 kilograms is attached. Is my voice clear?
Yeah, it's clear.
Okay. A block of mass 1.6 kilograms is attached to a horizontal spring that has a force constant of 1,000 newtons per meters. As shown in the top figure, the spring is compressed 2 centimeters and is then released from rest, as in the bottom figure. A. Calculate the speed of the block as it passes through the equilibrium position x equals 0 if the surface is frictionless.
Okay, so we have a case. It's like chapter 7. If you still remember, work is equal change in potential energy. We can call it U. So what is the potential energy of a spring? It's half kx square. So he gave us the value of k. And he told us that the compression is 2 centimeters. Now here is a common mistake. I saw it so many times. Students do it. When I say the compression is 2 centimeters, they will just write 2. And as a result, the calculation will be way off. The calculation will be way off. So it's 2 centimeters. Be careful. So in the first part, it will not matter if it is minus or plus in this because we have x squared. We are not talking about the force, we are talking just about the energy. So it does not matter what we are talking about. If we are talking about the force, then the sign is important depending on which force we are talking about, the spring force or the outside force. So what's the total energy of the spring? Half 1,000 and then 0.02 square. So what's this value? The sign of energy, when they say it's a minus sign, that means it's a lost energy. When we say this is friction energy, it's a wasted energy, it's a lost energy, so we give it a minus sign. Okay, so what's this value? Can somebody tell me? So it's 10 joule. So delta U is equal U2 minus U1. So it will be a 10 joule. That 10 joule will be transferred into work, which is, what is work? After it is released, is half mv square. So that means 10 is equal half. What's the mass of the block? 1.6 v square. So what is V? It's not 10. 0.2 square multiply by 1000 multiply by half. That's 1/5. Yep, it's not a 10. So then you can calculate V. So V, it's half a meter per second. Or we can just write it as an equation without numbers. So half kx squared is equal half mv squared. Half will disappear. So we end up with V is equal k over m x squared. You put the numbers, it will give you the same value. So do it the way you like it. Any question? طيب, let's do B. يا عادل, read for us B.
دكتور، بس كان عندي سؤال
اتفضل.
في السؤال الماضي.
تفضل.
دلوقتي لا بس على الصورة أكتر يعني.
على الصورة.
السترينج was compressed يعني it gained energy بس it gained to the left side. Now the velocity is going to be to the right side, right?
Yes.
Or this is the velocity.
Yeah, the velocity will be to the right side, yes.
Yeah, so shouldn't its direction be in the minus direction?
Why? You compress the spring. What do you expect when you
Yes,
compress?
because it's opposite of the compression.
Why you are confusing yourself? يعني, this is the original position of the spring, correct?
Yeah.
We compress the spring. And then we release it. So forget the sign. What will be the speed direction? Left to right or right to left?
Left to right.
خلاص, يعني if you want to give left to right and minus sign, give it a minus sign. If you want to give left to right a positive sign, give it a positive sign.
Okay, thank you.
Yeah, so it's you don't need to confuse yourself. And remember, when we talk about the force of the spring, we need to put a minus sign in the Hooke's law. F is equal minus x kx when we talk about the force of the spring. The force of the hand is equal kx. Okay?
Exactly, doctor. So the work should be in the negative direction as well. If F is negative, so work will be negative.
F is negative? You mean this one? The spring?
Yes.
Yeah, but the spring here, X is negative and K is negative, so they will cancel each other. Or if you want to like it, if you want to say it in another words, well, the spring did work. But that work of the spring, it's not from itself. It was done on the spring and then the spring did the work.
Yeah, okay.
Yeah, but he is not asking in this problem who did the work, or is the work positive or the work negative. In this question, he is asking just about the speed. And as you can see, just the speed. He didn't even talk about velocity.
Yes, true.
So no need
Okay,
to
thank
worry
you.
about the sign, because he's talking about the
Okay.
speed. And it's like when you lift an object and you put it on the table, and then that object is fall down. Well, the gravity itself didn't do the work by itself. We have work of gravity because we put the object on the table. If you are concerned about which is positive and which is negative, who did the work, he will take a positive sign. If it is a potential energy, then we give it a minus sign, just to distinguish that gravity itself didn't do the work. The mass itself, the spring itself, did not do the work by itself, but there is work done. So for that we give a minus sign, just to distinguish and to know that gravity itself didn't do the work. Gravity just restore back the energy you stored in the gravity, same as the spring. But in this typical problem, he has not talking at all about the sign. He just wants the speed. Okay, يلا يا عادل اقرأ.
Okay. B. Calculate the speed of the block as it passes through the equilibrium position if a constant friction force of 4 newtons retards its motion from the moment it is released.
From the moment it is released. يعني هلا starting from this point, let me enlarge it. هلا what he said, starting from this point, afterwards there is friction. The moment it was released, يعني starting from this point there is friction. And he gave us the force of friction. He gave us the force of friction. So now, instead of writing work is equal change in potential energy, we will write work is equal change in potential energy minus the work done by friction. تمام? Why? Because we will lose some friction, some energy due to friction. So delta U is half kx squared minus the work done by friction. What is the work done by friction? It is force of friction multiplied by x. تمام? So, and from this side we have half mv squared. So put the numbers. For Newton, he told us the force of friction, 4 Newton. So this will be equal 0.12. .39 meter per second. تفضل يا عادل.
Doctor, just a quick question. Why did we manage to like substitute the work with mv squared?
Well, because
Even in part A.
In part A, because we have the conservation. In part A, we have conservation of mechanical energy. What's the
Yeah.
meaning? That means whatever energy we have in the system, it will be just transferred from one kind to another. So originally, here we have an elastic energy, and then when the spring return to its equilibrium, that means all this energy has to be transferred into kinetic energy.
Yeah.
There is
So we
no
could have like written the equation in another way, which is delta K plus delta U equals 0, and then try to solve it.
Sure.
Because
Yes,
that way it kind of removes the confusion.
sure. You can do whatever you like. يعني for me this is an easier approach. يعني we are talking about the same thing. إنه ال change in kinetic energy plus the change in potential energy is equal 0, because it's a
Yeah.
conservative forces.
Yeah, but I don't get the same idea from the same approach you just like used right now.
Well, let me explain. So I said work is equal change in potential energy, but also work change in kinetic energy. So that means
Yeah.
change in potential energy is equal change in kinetic energy. Well, that means change in potential energy plus change in kinetic energy must equal to 0. Yeah?
Yeah.
Don't worry about the minus, because we are talking about change.
Okay.
So it's the same.
Okay. Now it makes sense.
Yeah, it's the
But
same approach.
because when I was reading the book,
Mhm.
he used the W, like which is the work, as the force over distance.
Force over distance?
I mean force multiplied by
4 multiplied by distance. That's correct.
yeah.
That's the
He didn't
original.
use it.
That's correct.
Yeah.
This is, if you revise chapter 7, this is how we started. We said work is equal F dot D, and then from there we proved that work is nothing but change in kinetic energy, and then we proved that work is change in potential energy, and then we proved that work is equal change in elastic energy. So if we have in one problem, if we have kinetic, potential, and elastic, we will have delta K plus delta P plus delta U, all must equal to 0 if the forces are conservative. It's not only delta U plus delta K is equal 0. No. Because when you have conservative forces, that means no gain to the system, no loss to the system. Summation of all. When friction, we need to deduct friction.
So we put it on the right side of the equation.
Yes, if you like to say that the change in all energies could be the work done by friction. Or if you just go to the beginning of the course, this chapter, we are talking about this.
Yeah, this equation literally helps a lot if we take this approach.
That's correct. So you can have a problem with all three together.
Yeah, I've seen one in the book.
Yeah. You can have a problem with all the three together. Like for example, I can start with an inclined plane with an object at certain height, and then I have an inclined plane at an angle, and at the end of the inclined plane here there is a spring. So here is my object originally. So you have point 1, you have point 2, and you have point 3, and on top of that you have friction.
And this kind of problems, like, does the question asks me about a specific point, or
Yeah,
how do
I can generate so many questions in that. So for example, I will ask you what's the total energy at point A?
it will be equal to the
mgh.
gravitational potential?
Yes. And then I can ask you what is the kinetic energy at point 2?
It will be all kinetic energy.
It will be potential energy minus the energy I lost for friction.
Oh, yeah.
And then here in the middle I can ask you, for example, point 4. I can ask you what is the speed at point 4.
So I have to, it will be the kinetic energy equal to the potential energy minus the friction energy.
Minus the friction, all the friction. And pay attention, at the inclined plane, the friction is different than at the surface.
Oh, we have two
Here,
friction.
yeah, here mg cosine theta multiplied by coefficient of friction. Here it's mg multiplied by the coefficient of friction.
Because of the normal force.
That's correct. And then finally, I can ask you how much the spring is compressed.
So here it will be the elastic energy equal to kinetic energy minus friction.
No, because total elastic energy minus the total friction will give me how much the spring will be compressed. Why you need to consider kinetic energy? Well, kinetic energy came from the potential energy.
Which is originally the
mgh. You see, so in this problem, I have 3 different types of energy plus friction.
But how shall I understand these concepts so I can solve them effortlessly?
Well, it's do you understand money transfer?
Yeah, I understand money.
Okay, so you start with $1,000. You start with $1,000. And then you convert your currency into Qatari riyal, so you lose some of your money to friction. You didn't buy anything.
Yeah.
You didn't buy anything. You just lose some of your money as when you transfer your money from one type to another. So that's friction.
Okay.
And then you went to a store and you bought some goods, and then you went to another store, you bought food, and at the end I will ask you how much left of your money.
Right.
So you need to consider your initial money, how much you spend for food, how much you spend for goods, which is 2 different things. Could be kinetic energy, could be whatever energy. And you need to consider friction, and at the end of the day you tell me, well, what's left for me is like 200 riyal.
Okay, so if I want to visualize the money concept on this inclined concept, I would say at point 1, I had my original money account, which is MGH. And
That's
at point 2, I will have the money account will have the friction deducted, so the total money will be MGH minus the friction from the incline.
Exactly.
And during point 4, Here I get lost at point 4.
Yeah, at 4, well, whatever left before I ask you how much money you have. So at 4, probably you bought food, or you bought drinks, or you bought some goods at 4. It's not the final point, because
Yeah, that's
still
the
after
final point.
4 you need you need to lose money for friction.
Uh-huh.
At 3, I will ask you what's the total money left for you. So you consider your purchases, you consider all your money that you lost due to transferring money due to friction, and you tell me, well, my total money is this amount.
So in other words, if I want to solve the problem for point 3, I still have to solve it for point 1, 2, and 4.
You need to solve for 1, consider the friction energy loss at the inclined plane, and then consider the energy loss at the normal plane. So here,
So
if we can say this is a force of friction 2, and you have force of friction 1, because they are different.
okay, so if I want to solve the problem for point 3, like if the question was calculate the energy or whatever it is for point 3, I have to calculate for point 1, 2, and 4.
Exactly. So it will be a change in potential energy minus work done by friction, and that should be equal change in elastic energy of the spring.
And the work done by friction is both from the incline and from the...
From friction force 1 and friction force 2. And if there is friction in the spring, we just solve it here. You see, this is when we have friction under the spring. So we consider force of friction, and we multiply the distance that it will grow inside. It will be compressed inside the spring.
Okay, makes sense.
Yeah, and as you can see, there is no need to mention the kinetic energy, because kinetic energy had its energy from the potential energy.
So it's basically the same.
Yeah. So we are talking about the same thing. طيب at point 2 مثلا هاي خلينا نكتب هاي point 3. طيب let's talk about point 2. About point 2, change in potential energy minus energy loss due to friction is equal change in kinetic energy. And this is at point 2.
Because the potential energy at that point will be transferred to kinetic.
Exactly, minus the force of friction 1.
Yeah.
Minus the energy loss due to force of friction 1.
Yeah, I get it.
So this is 1 and 2. This is 1. Type at point 4, well, change in potential energy minus the work loss done by friction 1, and minus the work done by friction 2 is equal delta K.
Okay. Yeah, now I understand.
So it's like you start with a certain amount of energy, and then you consider friction, because now we are talking about non-conservative forces, and then you deduct the friction, and then whatever left you convert it to whatever energy.
Is there any other sort of non-conservative energies that we will consider? Like, I know there's chemical energy and nuclear energy, but will that be involved in our questions?
No, in our questions we just give an example of friction force. So no need to worry about other forces. However, even if you have any problem, we told you that this force is non-conservative, we just take out how much it will consume from the energy, and we subtract it, and that's it. yeah, يا مان مبسوط على الفلوس. Yeah, it always work. Money always work. I agree.
I agree too.
Yeah. طيب any other question يا شباب؟ طيب خلينا نحل كمان واحدة. يلا read it for us.
A 3 kilograms crate slides down a ramp. The ramp is 1 meter in length and inclined at an angle of 30 degrees, as shown in the figure. The crate starts from rest at the top and experiences a constant friction force of magnitude 5 newtons. The crate continues to move a short distance on the horizontal floor after it leaves the ramp, and then comes to rest. A. Use energy methods to determine the speed of the crate at the bottom of the ramp.
طيب يلا خلينا نشوف information given for us. First of all, he told us the mass is equal to 3 kilogram. And he told us the force of friction is 5 Newton. And he told us theta is equal to 30 degree. And basically he gave us the height as half a meter. So use the energy method to determine the speed of the crate at the bottom of the car. Very easy. So change in potential energy minus work done by friction must equal change in kinetic energy. So mgh minus what's the work done by friction? It's the force of friction multiplied by d is equal half m v square. طيب let's put the number 3 kilogram 9.8 h is half meter minus the force of friction is 5 and already d is 1 meter. He already gave us d and d sine 30 is equal half. Even if he don't give you the value of d, you can determine that. So you do the calculation, V will be 2.54 meter per second.
Doctor, I had a small question.
تفضل.
Back in chapter 7, we took like a similar example where a man pushes a box up the truck. So, and it asks for the work. Do I, not potential energy or anything, he just asks for the work. Do I take the length 1 meter or the 0.5?
Was there friction ولا ما في friction؟
No, it's back in chapter 7. Simpler.
معناته شوف it will give you if you do f dot خليني اكتبها if you do so work if you do
it
f
will be force times distance.
Dot,
what's the distance here?
Dot yeah f dot
Yeah.
d or you do work is equal mgh, it will be the same. لأنه what is f dot d?
It's the work. done on the
I know, but what,
on the
how,
box.
how do we transfer, how do you translate the dot product?
Uh, the y, the y direction and the x direction.
Yeah, but what is, يعني, what's the meaning? What's the meaning of all f dot d? It's the component of f in the direction of d. It's the component of f in the direction of d. That's the dot mean. It's the component of f in the direction of d, or the component of d in the direction of f. So it will be the same. It will be the same. So either or, it will give you the same answer. طيب. Now let's talk about power. Let's talk about power. هلا power, we are used to the definition of power اللي هو work done in a certain period of time. That is power. That is power. So the unit of power is joule per second. Joule per second. And we call this watt. We call this watt. الحين he want to show us that we start with P is equal work over time, and he is deriving for us and to prove for us that, well, power could be also written as force multiplied by velocity. If theta is equal 0, so power is nothing but Fv. And this is the theta between F and V. So if the angle is 0, power is equal force multiplied by velocity, and also work divided by t. And the derivation is very simple. It's a change in work with respect to time. But what is change of work? It is force, change of displacement. Well, what is displacement over change of displacement over time? It's the velocity. It is the velocity. So again, we have a dot product, F dot V, and if the angle between them is 0, so power is Fv. Clear? So not only work over time, it is force multiplied by speed. Force multiplied by speed, and I dropped velocity because now we know that they are in the same direction. So what we care about is the speed. What we care about is the value of the velocity, the speed. If the angle wasn't 0, it's like a general case. We have a dot product. We have just a dot product. It's not only cosine, لأنه in some problems I will give you the vectors. So cosine will not do you anything. I will give you the vectors and I ask you to do a dot product for the two vectors. يعني for example, I will give you f is equal 3I plus 5J Newton. And I will tell you velocity was 4I plus 7J meter per second. Find the power. What is the power? So in that situation, you need to calculate the dot product. You need to do the dot product. So it's 12 plus 35. So that's 47. That's correct. 47 watt. Yeah, so we did that. Like if you review the videos, we did that. Joule per second, that's correct. Watt. It's not written like this. It is written like that. And it's the name of the scientist. Yes, the name of the scientist who discovered it. So it's not always a cosine. Be careful, and I can give you two vectors and I ask you what is the power of the two vectors. طيب. Here 1 watt is 1 joule per second. 1 horsepower. طبعا الجميع بيسمع horsepower. This car is 100 horsepower, 200 horsepower. So what is a horsepower? 1 horsepower is equivalent to 746 watt. And what is 1 kilowatt per hour? It is 1 kilowatt hour. Energy transferred in 1 hour at a constant rate of 1 kilowatt. That's the meaning. Like if you want to pay your electricity bill, they will give you, you will see this. You will see this. And the meaning of that, and the meaning of that is like every hour they give you 1 kilowatt. So if your consumption مثلا, suppose that you saw in your bill that your consumption was 70 kilowatt hour, that means you were receiving every hour 70 kilowatt. You are receiving every hour 70 kilowatt. When you see 70 kilowatt per hour. Yeah, it's unfortunately we have corona, but usually when I teach my students 191, usually I let them calculate their horsepower, their output horsepower. بنطلع من الصف بنروح على الجيم we put the treadmill in an inclined plane, we fixed the velocity, and right away we can calculate the power of the student. And 290 kilowatt. هذا الانجن تبع سيارتك 400 هورس باور. هلا من باب ذكر الشيء بالشيء هلا كل السيارات، كل مصانع السيارات لما تقول لك مثلا السياره هذا الانجن 200 هورس باور او 400 هورس باور, that is the experimental tested horsepower. يعني when they put the engine in the car and they attach the cooling pump and they attach the air condition and they attach other stuff to the engine, horsepower will drop dramatically. يعني for example I remember this example, Toyota Corolla مثلا, الموديلات اللي الانجن فيها هورس باور حوالي 110 او 120 هورس باور, when they put the engine inside the car and they attach all the things to it, horsepower will drop to about 70 horsepower. يعني you lose about 50 horsepower ولا 40 horsepower for that. So yeah, the engine could be rated to 400 horsepower, but when it is inside the car, it will drop. It will drop. طيب, let's try to solve a problem. ريد يا أحمد ولا شو مين اللي بضله يقرأ لنا؟ بضلني انسى الاسم. عادل, تفضل يا عادل.
An elevator car has a mass of 1,600 kilograms and is carrying passengers having a combined mass of 200 kilograms. A constant friction force of 400 newtons retards its motion.
4,000.
How much power?
Yeah.
A. How much power must a motor deliver to lift the elevator car and its passengers at a constant speed of 3 meters per second?
طيب. إذا شو الانفورميشن اللي عندنا؟ عندنا الماس توتال ماس تساوي 1600 بلس 200 يعني 1800 كيلوغرام. ب41 كيلو وات. أعتقد الإجابة غير صحيحة. هلا قاعدين بنحلها مع بعض. What other information? The friction force is equal 4,000 Newton. تمام؟ احنا شو اللي اخذناه؟ احنا حسبنا الباور if it is in the same direction, which is the case in this problem, is equal force multiplied by V. And he gave us that V, we can add it here, V 3 meter per second. So we know V. How about F? For F, now we need to write our famous equations. So we have tension. So the elevator is going up. Is going up. That means tension is positive, the rest is negative. So we have tension minus mg is equal 0. That's without friction. That is without friction. طيب, so this is without friction. تتذكروا كم مسألة حلينا؟ T is equal T minus mg is equal 0 لأنه ما في friction. طيب, when we add friction, well, it is T minus force of friction plus mg is equal 0. Or as Yaman wrote it, tension minus force of friction minus mg is equal 0. Well, this is exactly the same. Halla, if we have this kind of problem in the exam, I will give for this equation 2 marks, for this equation half a mark, and for the rest of the calculation half a mark. Exactly, it's equal 0 because speed is constant, يعني acceleration is 0. تمام? So if we have such a problem in the exam, I will give 2 marks if you wrote this equation, if you write this equation correct. I will give half a mark for this one and half a mark for the rest of the calculation. Where is friction? This is friction. High friction, force of friction. clear؟ طيب, now we wrote the equation. We calculate the tension, because the tension will enter into this force. This is our tension. So our tension is equal force of friction plus mg. يعني force of friction is 4000 plus 800 multiplied by 9.8. So our total tension 21,640 Newton. Now we put it in our equation. 640 multiplied by 3. So it will be 6492 watts. So where is the physics in this problem? Well, the physics is, can you write this equation or not? That's the physics. And then, well, the power is force multiplied by velocity or speed. Force multiplied by speed. So لاحظ هون صحيح انه elevator it's not you are not touching anything. من وين بيجي الفريكشن؟ الفريكشن زي ما قال زميلكم احمد عبده، الفريكشن بيجي من الكيبلز والموتور والحركه و الى اخره. But there is a force of friction. Air resistance, yeah, but if you still remember, at low speed it's 3 meters per second, so at low speed air resistance can be neglected at 3 meters per second. طيب, let's do part 2. Read it for us.
Okay. B. What power must the motor deliver at the instant the speed of the elevator is v, if the motor is designed to provide the elevator car with an upward acceleration of 1 meter per second square?
أيوة, إذا الآن this part we have acceleration, so the equation will be written as T minus force of friction minus mg is equal ma. And here I will give this 2 marks and the rest 1 mark. So let us compare it with the previous equation. T minus force of friction minus mg is equal to 0 because there is no acceleration. Now we have acceleration is equal ma. تفضل.
حضرتك بتقول مثلا على الايكويشن دي عليها درجتين وكده. انا لو يعني مش ضروري اكتب يعني مثلا تي ماينس اف فريكشن ماينس ام جي وكده، ولا ممكن اعوض بالارقام على طول؟
حتى لو عوضت بالارقام ماني بصلح الارقام، يعني حشوف ارقامك صح ولا مش صح.
يعني مش ضروري يعني السيمبلز ممكن اعوض بالارقام على طول.
مظبوط، بس ما هو يعني اذا عملت غلط في الارقام نفس الشيء.
صح، وافضل انا لو كنت غلط في الارقام فعلا. صح.
تمام. اذا البيف الفيزيكس في هاي المساله هاي الايكويجن، هذا الفيزيكس تبعها. والساينس طبعا لانه حكينا الاليفيتر از موفينج اب معناته T is larger than mg، معناته T positive و mg negative. طيب if it is moving down يا أستاذ معناته T أصغر من mg، معناته mg minus T. طيب this is our equation. So then we calculate T. T in this case will be 4,000 plus 1,800
12 o'clock p.m.
multiply by 1 اللي هي MA يعني let me يعني T is equal MA plus MG plus the force of friction يعني تساوي 1800 multiply by 1 plus 1800 multiply by 9.8 plus 4,000. نيوتن. الحين لاحظوا here this one and this one because it's moving with upward acceleration. Now the tension is larger. The tension is larger and the power is also force multiplied by velocity or speed 2344 0 multiplied by 3, so that is any question يا شباب؟ A 3 from here. يعني الكارت نفسها سرعتها 3 meter per second but with an acceleration of 1 meter per second square. Yeah, in real situation, yeah, at the beginning you have acceleration, but then that acceleration will become a 0. Yeah. Yeah, if it is acceleration from 0 then it's a different story. يعني أنا بلاحظ كثير مسائل الكتاب بيختصر التعقيدات. يعني زي هاي المسألة ما حكى لنا إنه calculate the force if the elevator is moving at 1 meter per second starting from 0. لأنه هيك بصير every second velocity will change. Every second velocity will change. But he made it simple. He assumed that speed is 3 meter per second and we want to accelerate as a 1 meter per second square. يعني بتلاحظوا كثير في المسائل تبع الكتاب انه بيختصر التعقيدات. ما حجيب أسئلة أكثر تعقيدا من المحطوطة في الكتاب. ما حجيب أسئلة أكثر تعقيدا من المحطوط في الكتاب. طيب هيك بكون خلصنا chapter 8. إذا شفتوا حطيت لكم التعديلات اللي حطيناها على الهوم وورك والكويزز في البلاك بورد علشان you adjust يعني. و if you have no question let me stop the recording.